Greetings, I am Salise and I will be reporting about laser type level sensors, its principles of operation, technical design, types, material use, measuring ranges, and lastly, its limitations. For principles of operation, laser type level sensors has four main parts to note. First is the emitting laser beam. It uses a laser diode to emit a focused and narrow beam. This laser beam is directed towards a surface. Second is reflection. When the laser beam hits the material surface, it is reflected back towards the sensor. Third is the distance calculation. The sensor's internal electronics processes the time of flight or triangulation data to calculate the distance from the sensor to the material's surface. Lastly, the output, often in the form of an analog voltage or current, a digital signal, or a communication protocol, is sent to a device or monitor for measurement, viewing, and control. Next, for technical design, laser type level sensors has common components that you can find. These are laser emitters, optics, detector, signal processing, calibration, output, enclosure, and lastly, power supply. Types of laser level sensors. There are commonly two types of laser level sensors: triangulation and time-of-flight sensors. For triangulation type laser level sensors, it measures the angle at which the reflected laser beam returns to the laser sensor. For time-of-flight laser level sensors, it measures the time it takes the laser to reflect from the surface back to the laser detector. Common materials used in industrial laser type level sensors include aluminum alloys and stainless steel for corrosion and resistant sensor housing. Plastics, for example, PVC and PTFE, used for sensor components that come into contact with the measured material. Glass for laser optics. Ceramics for high temperature resistance and electrical insulation. And lastly, for silicon rubber, it is for seals and gaskets to provide a watertight and dust-resistant seal for the sensor's housing. These materials are chosen based on factors like the sensor's application, the substance being measured, and the environmental conditions. Measuring range, typically determined by the sensor's design, characteristics, and the intended application. For short range, up to 10 meters, for batch processing, wastewater and sewage, food and beverages, laboratories, and etc. Medium ranges from 10 to 30 meters, large tanks and silos, water treatment, oil and gas industry, mining and quarrying, and etc. For long range, 30 meters plus, water reservoir, dams, port and harbor monitoring, marine and offshores, and etc. Limitations. Some of the biggest limitations for the laser level sensors are visibility and environmental factors that can be affected by dust, moisture, or fog, extreme temperatures, particularly in high temperature or cryogenic applications, reducing device performance, dynamic environment accuracy. For moving or turbulent surfaces, laser sensors may require additional compensation or signal processing to maintain accuracy. Maintenance. For optical components, it may require periodic cleaning and maintenance to ensure accurate measurements. And lastly is the cost. High-quality laser sensors can be relatively expensive, especially for long-range or specialized applications. That will be the end of my report. Thank you for listening.